The magnetic field of the Earth protects us from solar winds entering the Earth's atmosphere. Scientists have discovered that the Earth's magnetic field has reversed itself numerous times since the Earth formed over 6 billion years ago. Rocks on the ocean floor have iron-bearing minerals in them called magnetites, and scientists use a cool instrument called a magnetometer that actually records the direction of the Earth's magnetic field found in these rocks on the ocean floor. Right now, the Earth's magnetic field is running at northern polarity, which means that the Earth's magnetic field is actually exiting the South Pole and running north and entering the North Pole. Exiting the South Pole, running north, entering the North Pole. And it continues in this northern direction. So what happens when the Earth's magnetic field reverses itself, what's going to happen for southern polarity, it's going to actually exit the North Pole, move down in a southerly direction, and then enter the South Pole. Up through the mantle, core of the Earth, exit through the North Pole, and then again move in a southerly direction, and then eventually entering the South Pole. And it's going to go in that southerly direction until it reverses itself. So we're going to do a demonstration on how magnetic reversals actually support Harry Hess's theory of seafloor spreading. So what I actually have right here is a very common demonstration actually that has to do with magnetic reversals. So you see South America over here, Africa right here. This part right here is going to represent what's eventually going to be the Mid-Atlantic Ridge. So these are the times of Pangea when South America was fitting up against Africa. So the movement of these continents actually has to do with what's going on underneath the Earth's crust. So what's going to happen is that magma is going to come up and it's going to cool and harden and it's going to form rock. Now, these rocks right here, the magnetites are actually indicating northern polarity. So at this time right here, the Earth's magnetic field was running at northern polarity. As you can see, South America and Africa are starting to move away from each other. Then over a million or so years, more magma comes up and cools, hardens, and these rocks are indicating southern polarity. So this means that the Earth's magnetic field has reversed itself because these are showing southern polarity. South America and Africa are continuing to move away from each other, and this is starting the formation of the Atlantic Ocean. So more magma comes up at mid-ocean ridges. Magnetic reversal has taken place because these rocks are indicating northern polarity. South America and Africa are continuing to move away from each other. A couple million years later, magma comes up and cools, hardens, and these rocks right here are indicating southern polarity because the magnetites in them are running south. All the while, the Atlantic Ocean is getting bigger, and South America and Africa are continuing to move away from each other. Years later, magnetic reversal takes place, and these rocks right here are indicating, the magnetites are indicating northern polarity. And then finally another magnetic reversal takes place. These magnetites in these rocks are showing southern polarity, and another magnetic reversal has taken place. Now you have the Atlantic Ocean right here, and then 2,000 miles of Atlantic Ocean water is now separating South America and Africa.